Now that we've spent some time doing right triangle trig, we can go look at triangles that are not right. So we're going to use two things, law of sines, law of cosines. Law of sines is actually a little bit easier than law of cosines, so why we're starting with this one. So we've spent tons of time with right triangle stuff. We're now going to look at oblique triangles. Okay, so if none of the angles is a right angle, it's oblique. You can have the triangle on top there with all the angles acute, so smaller than 90. You can have this guy down here with two acute angles and one obtuse one. Okay. Now, when I give you information, you're not always going to know what the triangle is going to look like. So you can't always trust the pictures you draw, and you'll kind of see that as we go through these. Okay. Here's the law of cosines right here. Okay. All it really says, sine of angle A over A is equivalent to sine of angle B over side B is equivalent to sine of angle C over side C. So we're introducing this lambda here for side C because before it was a right angle, so we never had to worry about that, and the sine of 90 is just 1. Okay, but when we have this, because there's no right angles now, so we need three different angles. So basically sine of the angle corresponds to the side. Now when you're setting these up, you don't want all three there. You only want to pick two of them at a time. So maybe you want to pick this and set it equal to this, okay? Or you want to pick B and B and C and C, okay? But you don't want to set all three of them up because you don't want two equal signs. Okay, so it's basically 3 choose 2. There's 3 different things you can do with this. So we know where this formula comes from. We're going to do a quick little proof here. Okay, so we're going to take triangle here. Notice there's no angles that are 90 degrees. So this angle up here may look like it could be a 90, but you'd have a right angle thing in there. Okay, so we're going to call this C, A, and B. We're going to drop an altitude H down. Okay, so I'd encourage you guys to pause it here and try this for a little bit. It's actually quite quick. If you want to see it, just keep rolling with this. So the first thing we want to do is go put the appropriate things in here. So you got to know angle A is going to be across from side A because angles determine sides. Okay, beta is going to be this whole thing right here. And then lambda is going to be across from C. Okay, and here's what you want to do. Let the altitude be an H. So this guy we drop down that's perpendicular, we're going to call that H. Write an expression for angle C and angle A. Now, we've taken one oblique triangle here and we split it into kind of this triangle over here on the left and this triangle over here on the right. Because we created a 90-degree angle, we can do something with this. Okay? So if I say, write an expression for angle C. Well, angle C is this guy down here. I'm going to use the H because I can frame it with both that left and right triangle. So I'm going to say sine of lambda is the same thing as height over A. Opposite is my altitude over hypotenuse of A. Do the same thing for angle A. So if you guys want to pause it here and see if you can take what we're about to do here and turn it into this stuff here, I'd encourage you to do that. I'm going to come over here to angle A. I'm going to do the same thing. And I'm going to say sine of alpha, opposite of an H, all over side C. Now if I get two different expressions here and they both have an H in them, you're just going to do a little substitution. So what I'm going to do is take this guy here and say H is the same thing as A times sine of lambda. Notice you don't want to put that A out on the edge. You want to put it before the sine. I'm going to take this guy here and say h is c times sine of alpha. So basically just multiplying across here. Now, if you set this expression equal to that expression right there, and then you divide each of them by a, and then you divide each of them by c, you'll have law of sines. This guy right up here. And to get the one in the middle here, we would just relabel these things because we don't want to do anything here with this b because it doesn't have any relation to h, so we could just change the labels around. Okay, but if we know two of them have that same ratio, then the others do as well. Okay? Law of sines is pretty easy to have memorized. Obviously, it's on your yellow sheet as well. Okay? So we got sides A, B, and C, opposite angles alpha, beta, and lambda, and there's your law of sines. Now, you can have three different cases with this. Okay, we're going to look at the first couple here today. This two triangle one gets a little tricky, so we're going to look at that in a second day. You can use law of sines for one triangle. You can use the law of sines to find a no triangle. Okay, and we'll come back to this guy here. So when I said you may have a difficult time getting a picture, or your picture may not look correct, okay, so it's you got to trust the formulas and not your pictures you create. If they give you a picture, you can assume that one looks to scale. So something like this. So they give you angle A, they give you angle B, they give you side A. Okay, if they give you a picture, you can have an idea what this guy looks like. Else, you can try and draw one, just it may not be to scale with what you drew. Okay, so when we say solve this triangle, there's 6 pieces, so I want 6 things in the answer. Okay, they have to give you some startup in order to do these things. So basically, we're looking for whatever's not there. Now, the book and the place where we get these notes tells you what the geometry theorems are. Okay, I don't worry too much about those because I just use the formula. I'm going to teach you guys how to interpret what we get out of this. Okay, so if we look at the picture here, let's save this little area up here nice and neat for all our answers. If we know alpha and we know beta, well, lambda has to be 80. Okay, it's going to be the easiest thing there because we know all triangles are 180. And that works. Now, you can use this the lambda when you're doing law of sines. But if you screwed up the initial answer, everything you do afterwards will also be screwed up. So if you use what they gave you, you're guaranteed to make less mistakes. If they give me angle A and side A, I'm automatically going to use those. Sine of 30 over 5. Okay. They give me angle beta. So I'm going to throw that guy in there, and this is going to make me solve for B. Okay? And again, I don't want to put anything else in here because you're not doing 2 equal signs. You're just picking 2 of these 3 things to put together. Okay, so we get this guy here, and then it's all just math from there. So I'm basically going to multiply the B across. I'm going to multiply the 5 across and divide by sine of 30. And it is super important that you put these in your calculator correctly as well. So make sure you're still in degrees. Okay, I'm going to do 5 sine of 70. Make sure that guy gets closed up or you hit enter and then hit what you want to do next. We want to take that answer, we want to divide it by sine of 30. Okay, 9.39. When you look at your answers here, you can round a little bit, but do try and keep a couple decimals because over time it'll jack up a bunch of answers. So I see angle B is 9.4, I'm sorry, side B is 9.4. Angle B is much bigger than angle A, so side B must be bigger than side A as well.